Okay, imagine this for a second. What if you had a single AI that could look at a picture, understand language, listen to music, and even master a super complex video game, all without changing a single line of its core code? Well, today we're diving into a paper from DeepMind that takes a massive step in that exact direction. It's called Perceiver IO.
So here's the game plan. First, we're going to talk about what I like to call AI's one-trick pony problem. Then we'll look at the first step towards a fix, a model called Perceiver. After that, we get to the big I/O breakthrough that really changed everything. And of course, we'll see this thing in action, one model with a whole lot of talents. Finally, we'll tie it all together and see what this means for the huge quest for general AI. All right, let's jump right in. Section 1, AI's one-trick pony problem. This really sets the stage because it gets to the heart of why most AI models out there are specialists, not the do-it-all generalists we see in the movies. So this brings us to the central question, right? Can we get a single AI to master language and vision and even go head-to-head in complex games? For a really long time, the answer has been a pretty firm, nah, not really. The reality of AI today is that most systems are built for just one job. You've got a language model that's a genius with text, but you show it a picture of a cat and it's completely clueless. You have a vision model that can spot that cat in a heartbeat, but has no idea how to play StarCraft. This means people have to build these incredibly complicated systems, basically stitching together different specialized models for every new task. It's like having a toolbox where every single tool can only turn one specific screw. Super inefficient. And look, this isn't just my take on it. It's how the entire field has pretty much always worked. The researchers put it perfectly in the paper, saying most machine learning research focuses on building bespoke systems to handle the stereotyped inputs and outputs associated with a single task. It's a powerful approach, for sure, but man, is it inflexible. So how do we start to break out of that box? Well, that brings us to the first piece of the puzzle, a new way of thinking about perception. And this is where we meet the predecessor to our main character today, the original Perceiver model. The original Perceiver was a really big deal. Its breakthrough idea was that it could handle all sorts of different inputs. We're talking images, audio, text, whatever you throw at it. And it did this by first boiling everything down into a compact universal summary. Think of it like a universal translator, creating a shared internal language that the main network could understand no matter what the original data was. And this slide right here shows both its genius and its one single fatal flaw. On the left, what it did really well, handle a ton of different inputs without needing a rewrite. Amazing. But on the right, you see where it stumbled. It could only produce super simple outputs, basically just a single classification label like cat or dog. It could listen to anything you gave it, but it could only say one word back. Not quite the generalist we're looking for. So that's the million-dollar question, isn't it? How do we get from a simple label to generating something rich and complex, like a full sentence or a detailed analysis of an image? Well, this is where the I/O breakthrough comes in, adding flexible outputs with this just beautifully elegant architecture. Enter Perceiver I/O. The I/O, of course, stands for input/output. It introduces this incredibly simple but powerful idea, a read, process, write architecture. The old Perceiver could read anything, but now, with Perceiver I/O, it can write anything too. Here's how the whole thing works, in 3 simple steps. First, step 1 is encode, or read. The model takes the input, image, sound, whatever, and distills it into that compact summary we talked about. Step 2 is process. A deep network just chews on that summary, finding all the important patterns and relationships inside. And then, step 3 is decode, or write. This is the magic part. Specific queries are used to ask the summary questions, which generates the structured output. You want to know the color of a pixel at a specific location? There's a query for that. Want to generate the next word in a sentence? There's a different query for that. It's brilliant. And here is the secret sauce that makes this all practical. This model scales linearly. You see, standard transformer models, the kind that power a lot of today's big AIs, scale quadratically. What that means is, as the inputs get bigger, the amount of computation they need absolutely explodes. It becomes a huge bottleneck. Perceiver I/O dodges that completely, which lets it handle massive inputs and massive outputs super efficiently. Okay, so the theory sounds amazing, but does it actually work? Well, in this next section, we get to see the proof. Let's see how this one model performs on some radically different challenges. First up, language. On the standard GLU benchmark, Perceiver IO performs right on par with BERT, which is a super powerful transformer model. But here's the real kicker. It does this by processing the raw text, the raw UTF-8 bytes. It doesn't need a special, complicated, handcrafted tokenizer to chop up words into little pieces first. That simplifies the whole process like you wouldn't believe.
Now let's talk vision. This task here is called optical flow. The AI has to predict the exact motion of every single pixel between two frames of a video. It is an incredibly difficult problem. And guess what? Perceiver IO achieves state-of-the-art results, and it did it without any of the specialized, custom-built parts that other models need for this task. It just learns to see motion.
Okay, so what about our really complex game? The researchers basically dropped Perceiver IO into the brain of AlphaStar, the AI that plays StarCraft 2 at a world-class level. It replaced a core part of the system, and get this, it matched the original agent's win rate while using 3.5 times fewer computing operations. It's more efficient with the exact same elite performance. Now, this might be the most mind-bending example of them all. For this test, the model was fed video, raw audio, and a classification label all at the same time. Its job? To reconstruct them. So on the left is an original video frame. On the right is the frame that Perceiver IO recreated after processing all three data types together in its one unified space. It is literally learning to see, hear, and classify all at once, as one single task. So all of these incredible examples, they all lead us to the big picture, the final takeaway. We're talking about the quest for general AI, and why a single flexible model like this really could change everything. So why does all this matter so much? Well, for one, Perceiver IO drastically simplifies how we build AI. It gets rid of the need for tons of special purpose engineering for every new problem. It scales up efficiently to handle huge amounts of data. And maybe most importantly, it's a huge conceptual step towards a true general purpose AI, a single model that can learn to do almost anything you ask it to. You know, the authors themselves say it best. Perceiver IO offers a promising way to simplify the construction of sophisticated neural pipelines and facilitate progress on multimodal and multitask problems. It's less about building 1,000 different specialized tools and more about forging one master key. And that leaves us with one final, pretty big thought to chew on. If one model can truly learn to do almost anything, what on earth will we ask it to do next?